adjacent buildings and shading devices can impact building energy consumption. Let's use the same thermal model in Des Moines as we used before. The EUI is 384. Build the random symbol mass models surrounding the target building. Select the context buildings and click on the Add Shading icon. Now these geometries cast shadows on the target building and thus affect the energy consumption. The EUI is increased to 385. This is due to the obstruction of the passive solar energy into the building by surrounding buildings in a heating dominant climate. Let's try another example with the same building but at a different location. Hide or delete the surrounding buildings. Delete the thermal zone. Select Phoenix as the site location. Select Box and add a thermal zone with the default settings. Run the simulation. The EUI is 157, with a large portion of the energy consumed for space cooling. Let's model a 2 meter by 30 meter shading. Let's add geometry as shading and run the simulation again. The EUI is now 159, which is worse than before. You would expect a shading device to be beneficial in a hot climate. If you check the glazing properties, you can notice that the solar heat gain coefficient is 0.21. This means that the glazing is already quite effective in shielding off solar radiation. What if we change the glazing to a higher solar heat gain coefficient? Let's hide the shading and simulate. The EUI is 150. It is lower than before because the other properties of the glazing also changed. Let's include the shading and simulate again. The EUI is 146, a 3% reduction. What you can see here is that shading design is not an independent variable. Designing shading devices is a complex subject and should be holistically considered based on many other factors, such as climate, glazing properties, internal loads, building orientation, occupancy schedule, etc.